So we've talked about how we can prove two triangles congruent. We've talked about the side-side-side congruence, and we talked about side-angle-side congruence. Today we're going to look at a couple new ways to prove triangles congruent called angle-side-angle or ASA, and then angle-angle-side or AAS. And those two things look very similar to each other, but we're going to find out that they are slightly different. So let's jump in by looking at this question. It says, how many possible triangles can you determine when given two angles in the included side of a triangle? Or another way to put this, let's say I had these measurements that needed to go into a certain triangle. It had to have a side called AB that was 8 units long, and an angle A that was 30 degrees, and an angle B that was 45 degrees. So let's look at that. Let's go ahead and try and sketch out what this possible triangle might look like. So I'm going to go ahead and start with segment AB that's going to be 8 units long. So I'm going to put point A over here, and then point B is going to be 8 units away, which would be about right there. So here's segment AB. That's going to be one side of my triangle. Now angle A, it says, needs to be 30 degrees. So that means it needs to come out, let's see, about a 30-degree angle would be something like this. So it doesn't say how long this side is, so I'm just going to kind of put this dotted line out here and say, okay, it's going to be a 30-degree angle right there, but I don't know how long that's going to be. And then angle B needs to be a 45-degree angle. So let's go ahead and put that. A 45-degree angle would look something like, oops, sorry, I didn't mean to do that. Let me just erase that. A 45-degree angle is going to look something like this. But we don't know how long that's going to be, but it'll be 45 degrees right there. But if we think about it, these two sides, even though it doesn't say how long they're going to be, by the fact that we have determined the length of segment AB to be 8 units, and we have one side over here coming out at a 30-degree angle from point A, and then we have this other side coming out at a 45-degree angle from point B, even though it doesn't say how long these two sides would be, we can kind of see exactly how long they would need to be. They would need to be a length such that they meet right there. So point C, if we were going to call this triangle triangle ABC, point C would have to end up right there. Now somebody else might say, well, what if you were going to take these two angles, 30 degrees and 45 degrees, and maybe send them off maybe this way for the 45-degree angle, and then kind of down this way for the 30-degree angle, right? Wouldn't that create a different triangle? Well, no, not really, right? Because we can see that if point C, let's call this point C1, like the first possible location for point C. Down here could be point C2, the other possible location for point C. We can see that these two triangles, triangle ABC1 up here and triangle ABC2 down here, they're really identical triangles. They're just reflected versions of each other. So what this is pointing out to us, what the idea here behind this example is that if I have these constraints, if I have these requirements that segment AB has to be a certain length, angle A has to be a certain angle measure, and angle B has to be a certain measure, then there's really only one triangle that I can build using those measurements. And so what that tells us is that anytime we would be looking at two triangles that have the same the same units, the same measurements for one side and for the angles at the end of that side, then those two triangles would be congruent. And so we can see that illustrated here in the angle-side-angle congruence criterion, or the angle-side-angle postulate. It says that if these two triangles have a side that's congruent, and they have the angles at the end of that side congruent, then these two triangles will be congruent. So here I have an angle, let's kind of mark this up. We have an angle right here congruent to an angle right here. We have a side right here congruent to a side right here. And then we have another angle down here congruent to an angle right here. And so we have what we call ASA, or angle side angle, where we have a side and then the angles on each end of it congruent to a side and then the angles on each end of it. and that makes our two triangles have to be congruent. And just as a reminder, remember when you're making these congruent statements that we're naming these triangles in such a way that it tells the person looking at our diagram which parts are congruent to which. So we can see angle M and angle S are congruent, and therefore they ended up both in the same place in the triangle's names. Angle N and angle T are congruent, so they both ended up as the third letter, and that left angle L and angle R to be congruent as the second letter here. So here we have another picture that says, we can see we have three different triangles, and it first asks if these two are congruent. Are these two here congruent? And I'll notice, I like to color code things. You guys know that by now. I notice that angle J and angle M are congruent, right? Angle J is congruent to angle M, and that's a pair of angles. I notice that segment JK and segment MN are congruent. So segment JK is congruent to segment MN. That's a pair of sides. And then I notice that angle K right here and angle N right here are congruent. Angle K is congruent to angle N, and that's another pair of angles. So I notice that I have two angles, right? And I have the side that kind of connects them. And so that would tell me that yes, these two triangles are congruent by angle, side, angle. So let's go ahead and say yes, triangle JKL is congruent to triangle. Okay, so J would be congruent to M, so I'm going to start with M. K is congruent to N, so next will be N. And then last L and O are congruent. So I'll put O at the end of that triangle's name, and I'll say by angle, side, angle. Now at the bottom here we have another question asking about this far left triangle and the triangle on the far right. And so this is kind of where it does get a little bit tricky, because I notice that angle J is congruent to angle P. All right, let's go ahead and color angle P the same color as angle J, right? Angle J congruent to angle P, which is a pair of angles. And then I notice that I have a segment congruent over here, segment RQ and segment JK, it says are the same. They don't look the same to me, but it says they're the same, so we'll go with it. So segment JK is congruent to segment RQ, which is a pair of sides. And then lastly, I have angle K and angle O congruent. Angle K is congruent to angle, I guess that's Q, angle Q. And that's another pair of angles. So a lot of people will say, oh yeah, this is angle, side, angle again. See, I have two angles and a side. But what I'll need to notice is that while on triangle JKL, those parts are in like the right place for ASA, right? We have a side, and then the angles that are on the end of it are the ones that have the markings on them. When I go over here to triangle PQR, that's not the same thing. We have these two angles, but then the side that's marked congruent, or the side that we've listed out as congruent, is not the side that connects the vertices of those angles. It's this other side over here. So in this case, angle, side, angle doesn't actually work, because angle, side, angle is really kind of the requirements for angle, side, angle are only being fulfilled over here with regards to where the side is located. Over here, it's two angles and then the side that's not between them. So what we have to say on this one is we have to say no, not enough info. Not enough info. Or we could maybe explain that we could say segment RQ is not included between angle Q and angle P. That could be our explanation. So now let's think, if angle, side, angle can prove that two triangles are congruent, what about angle, angle, side? So I have in this picture here, I have two triangles where I have two angles and what we'd call a non-included side congruent. Angle A congruent to angle X, angle C congruent to angle Z, and then segment CB and segment ZY are congruent, but those are not the included sides between the angles that we've marked. So the question is, what about if I have two angles and then the side that's not between them? Is that enough to show that our triangles are congruent? And what we can look at is we can say, well, wait a minute, we already know angle side angle works. And if I just look at the angles that I have marked in these pictures, angle A and angle X, angle C and angle Z, those are congruent. That would mean that it would be impossible for angle B to not be congruent to angle Y, right? Because if angle B and angle Y were not the same, then it would be impossible for both of the sets of angles in these triangles to add up to 180, right? Because A and C are going to add up to the same number as X and Z. Those angles are going to add up to the same total. And A, B, and C all add up to 180. X, Y, and Z all add up to 180. So angle B has to be congruent to angle Y. That's actually called the third angle theorem. I'll write that out here to the side. That's called the third angle theorem, which says that if two angles of one triangle are congruent, I shouldn't have put a comma there, to two angles of another triangle, then the third angles, that's where it gets its name, then the third angles are also congruent. It's called the third angle theorem. And so if we think about it now, you'll notice that originally we had these kind of turquoise or these teal parts marked congruent, but then we realized, oh, these angles would have to be congruent as well. And now what you'll see is we would have the triangles congruent by angle side angle, two angles in the included side, these two angles in this included side. So since ASA works, we can actually also take that and say, well, that means angle side would also have to work because of the third angle theorem, making these remaining two angles have to be congruent to each other. So that gives us our fourth different congruence criterion for triangles. If you recall, we already had side side side, we had side, we had angle side angle, and now we also have angle side as ways of proving that two triangles are congruent. And so the official wording of angle side says that if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So again, if we have our two angles marked here and here, and then a side that's not connecting those two angles, right? If that's what we have marked on one triangle, and then we have the same situation happening on another triangle, two angles congruent, and then a side that's not connecting them together, also congruent to over here, then our two triangles have to be congruent. All right, so let's look at these four pairs of triangles and decide if the pairs of triangles are congruent by any of our four criterion, or if there's just simply not enough information to say that they would have to be congruent. So I would encourage you to pause right now and try and decide on your own for A, B, C, and D whether the triangles are congruent by SAS, SSS, ASA, or AAS, or if there's just not enough info. So then let's take a look at A. On A, we notice that I have two angles and then the side that connects them on this triangle on the left. So I'm automatically, right away, I'm thinking, hey, this, the way it's marked now, makes me think about angle side angle because I have two angles and then the side that's between them. And if I look at the triangle on the right, I have the same situation. This angle congruent to this one, this angle congruent to this one, and then the side that connects these two angles is congruent to the side that connects these two angles. So I'm going to say for letter A, I'm going to say yes by ASA. If I go to B, I'll notice that on the left-hand triangle, all three sides have the marks on them. This side is congruent to this side over here. This one is congruent to this one, and this one's congruent to that one. And so on the triangle on the right, all three sides have the marks. So that tells me, this is a pretty easy one, that these two triangles are going to be congruent by side, side, side. Now next up on C, I'll notice that I have this angle congruent to this one. I have this angle congruent to this one. And then I have this side congruent to this one. So again, I have two angles and a side. But the side here and here is not the side that connects these two angles together. It's what we call the non-included side. So over here I have two angles and a non-included side, and up here I have two angles and a non-included side. So that tells me this one is going to be yes by angle, angle side. Finally, on D, on the left-hand triangle, I can see that I have two sides and an angle, and on the right-hand triangle I have two sides and an angle. So I might be thinking about SAS, because that's the two S's and one A, right? Two sides and an angle. But if I look more closely, I notice that my angle here and here are the ones that are congruent. But then this side is congruent to this side, and this side is congruent to this side. So while on the left-hand triangle, I have two sides in the included angle, on the right-hand triangle, I have two sides, and then I have a non-included angle. So for this one, although it looked initially like maybe SAS would work, we're going to have to say not enough info. Not enough info, because we don't have SAS for both of them. This one over here, the triangle on the right, is more like the SSA case, which we learned doesn't actually guarantee that the two triangles would be congruent. It has to be SAS, two sides and an included angle. All right, last one for this video. We're going to look at a problem that's asking what additional information would be needed to show the triangles congruent, first by ASA and then by AAS. So let's first just write out what we know, right? What we know. What parts do we know are congruent between these two triangles? Well, I know that angle A is congruent to angle D, which would be a pair of angles. Let's go ahead and color code those. And then I also know that segment AB is congruent to segment ED, or DE, and that would be a pair of sides. So I got this side congruent to this side. So if I just look at those letters there, I'm missing an angle for ASA, right? Because I have an A and an S, so I'm missing another angle. And remember, ASA wants that side to be located right between the angles that we're using. So if I have this side and angle A and this side and angle D, then the last pair of angles that would need to be congruent for ASA would be the angles at the other end of the side that we're using. So that would end up being we need angle B congruent to angle E. That's what would give us ASA for this first question. But if we want AAS for the second question, right here we have AAS, so now we want the side to not be in between the two angles. We want the side to be a non-included side. So let me quickly first just get rid of those markings we just put on for the last question, so not distracting us. Now we need this side right here to not be included between this angle and the other one that we're using. So that tells me it would need to be angle C right here. I would need angle C to be congruent to angle F in the triangle up here, because that way, again, this side is not the included side between these two angles.